Question 39. Use the properties of logarithms to expand the following logarithmic expression as much as possible. Logarithm of x to 4 times square root of x squared plus 3, all divided by 64 times x plus 3 to the 5th power, base 4. Quick review of logarithms. Logarithm is the function that gives you the power when you tell what base you're using and what's the total at hand. So logarithm of 8 with respect to base 2 is the power you need to raise 2 to get 8. You're asking that question and logarithm gives the answer. Sometimes it's a nice round number, sometimes it's not. Here it's just 3. Logarithm is the inverse function of exponentiation. So if you exponentiate b to x, and then if you ask the question, hey, what power do I need to raise b to get the total b to x? Well, it's like a riddle. The answer is in the riddle. It's just x. And that's for all x. The domain of a logarithm is positive numbers, but the domain of exponentiation is all real numbers. X can be anything. B to x will give you a positive number. And logarithm of x with respect to base b, if you raise b to that power, well, logarithm of x with respect to base b is the power you need to raise b to get x. If you use that power and raise b to that power, well, you get x. And that's only true when x is greater than 0, because the domain of logarithm with respect to any base is positive numbers, which is the range of exponential functions. And there are 3 easy points for the logarithmic function. What's the power you need to raise b to get b to 1, or just b? That's 1. And what's the power you need to raise b to get 1 over b? Well, 1 over b is nothing but b to negative 1. So what power of b is b to negative 1? It's negative 1. And what power of b is 1? Maybe I can write it more explicitly here. That's b to 1. So the power is 1. And so if you can write the total as a nice exponent, and 1 is b to 0, right? Then you can just write that power. That's what the logarithm gives. So if b is greater than 1, let's say b is somewhere here, then those are the 3 points on the graph. Maybe 1 over b is here. Think about 2 or something, or 3, some number bigger than 1. This is the graph of a typical logarithmic function, where b is greater than 1. If b is less than 1, then the graph looks like this. You can mark those 3 points, and that will tell you how you can figure out the shape of the graph from those 3 points. And we have some rules of exponentiation. And when you take the inverse rules, you get rules for logarithms. They come for free. So for logarithms, multiplication inside is addition outside. Division inside is subtraction outside. And a power inside is a coefficient outside. I mean, I can use symbols, I guess. So logarithm of m times n with respect to base b is the same thing as logarithm of m. Find the outputs and then add them. Same base. Division inside is if you have a division inside a logarithm, then you find the outputs first. And there's only one base, right, on both sides of the equation. Whatever it is, can be greater than 1, less than 1. It has to be positive. and the power inside, if you have something like this, and then you can write it as, you can bring the power to the front. And we have a change of base formula that's kind of handy. Change of base formula. If you have a logarithm with an old base that you don't want and you have somebody inside, right? I'll give an example. Maybe you need to compute logarithm of 7 with respect to base 2. It's not a nice number. So you want to use your calculator, but calculator has no logarithm base 2 key. So what you can do is you can switch to a new base, and clearly that's going to be wrong. You would need, let's use ln, natural logarithm. E is a number like 2.71, and ln of m, now 2 is different from 271. You would need a different power. So the way you correct is you use the same base at the bottom. On the right hand side, it's only the new base, and then you take the logarithm of the old base with respect to the new base. Here it's not m, but it's 7, right? So ln 7 you can compute on your calculator. ln 2 you can compute. So you take the quotient. All right. So what I'm going to do is I'm going to start with my expression. And the first thing I would do is, like, there are several choices you can make. We have to do a few things, but not necessarily in the same order. So I would look at that 64, and it's a nice power of 4. So I would write it, 64 is 4 to 3. That's the first thing that took my attention. So I would just write that. And then I would also write the square root as raised to 1 over 2. So I would write the expressions inside as much as possible as in terms of powers. Okay. And then one thing I like to do, that's kind of personal choice, because I don't want to make, I don't want to use multiple rules then where some of them can go wrong. I would convert everybody, I would move everybody to the numerator. So these two factors are already in the numerator. 4 to 3, 1 over 4 to 3 is the same thing as 4 to negative 3. Or x plus 5, 1 over x plus 5 to 5 is the same thing as x plus 5 to negative 5. So I would move everybody to the numerator, and then I don't have to deal with division. Everything is multiplication. Now I can use the rule multiplication outside, multiplication inside. Is addition outside. And break this big logarithm into multiple logarithms. And every time I see a multiplication side inside, I break the logarithm. And you have to be a little careful. So those are the factors. what's between the multiplication signs, right? And logarithm of 4 to negative 3 with respect to base 4, and logarithm of x plus 5 to the power negative 5 with respect to base 4. And what I do is I add them, right? Addition outside. And I can do one more thing. I can clean a little more. Power inside is multiple outside or coefficient outside. So that 4, I can bring it to the front. That 1 over 2, I can bring it to the front. That's negative 3, I can bring it to the front. I have to be a little careful. It's a negative number. Same here. I'll bring it to the front. And then I'll just write what's left inside the logarithm. Okay. And I'm almost done, except there is one more piece I can clean. The first term, I don't see anything I can do. The second term, the same thing. You have to be a little careful. There is no rule that says addition inside is something outside. So this is where we stop. And that plus minus, that's just a minus. And logarithm of 4 with respect to base 4 is nothing but 1. So that's just 3 times 1, which is negative 3. Well, there was a minus. Negative 3 times 1 is negative 3. And 5 times logarithm of x plus 5 with respect to base 4. Okay. Now, I didn't use this rule, division inside is subtraction outside. You can use that one, then you won't have to deal with negative 3 and negative 5 as exponents. But then you have to be a little careful. Like, you got to put minus in front of like if you don't have minuses here, you got to put the minuses in front of the terms. And sometimes people make the mistake, they put a minus, they don't put the other minus. So instead of that, I move everybody upstairs, and then I have to pay for it. I put a minus in front of the exponents, and then I just use this rule. Find it a little more foolproof. So let me check the answer real quick. What question is that? 39. Is it what we have? Yep.